Hello everyone. Let us complete section 12.3. As an application of exponential function, we have compound interest. So we will use this formula. This formula is used in banks to find the future amount. So A here is the future amount. P is the present value or initial amount. R is the interest rate as a decimal. T is the time in years. And N is the number of compounding in 1 year. So here N is depends. If the compounding are monthly, so N equal 12. If the compounding are quarterly, N equal 4. If the compounding are semi-annually, N equal 2. If it is daily, N equal 365. If the compounding is yearly, so N equal 1. For example, an initial deposit of $10,000 earns 8% interest, compounded monthly. How much will be in the account after 10 years? So here we need to find the future amount. We need to find how much in the account after 10 years. So A here is unknown. T here, 10 years. So the initial amount is equal to $10,000. The interest rate is 8%. Change this to decimal, which is equal to 0.08. Compounded monthly. So if the compounding are monthly, N equal to 12. Now apply this formula. A here equal P is 10,000. 1 plus R is 800 over 12. N is 12. Raised to the power N times T. N is 12 and T is 10. So 12 times 10 is 120. Now to simplify these two, so to add these two fraction, so make the denominator the same. So here 1, we can rewrite it like 12 over 12. So now we have the same denominator we can add. To add these two fractions, keep it 12. Just add the denominator. So 12 plus 800 equal 12.08 to the power 120. Now use the calculator to find 12.08 divided by 12. This is equal to 1.007 to the power 120. So to find this, to calculate this number, use the calculator and use this key, x to the power y. X to the power y. X here is 1.007 and y is 120. So 1.007 to the power 120 equal 2.3096. Multiply this number by 10,000. So we get A equal $23,095. So this is the future amount. So the future amount is $23,095, the amount after 10 years. So after 10 years, the initial deposit, which is $10,000, becomes $23,095. Now section 12.5, logarithmic functions. So here we have 4 objectives. Objective 1 is write a logarithmic function as an exponential function and write an exponential function as a logarithmic function. In section 12.3, the exponential function is discussed. So here y equal b to the power x, where b not equal to 1, b greater than 0. The graph of y equal b to the power x, this is the graph, is given, of y equal b to the power x, will pass through the following 2 points, 0, 1, and 1b. The domain for f is minus infinity to infinity, and the range of f is 0 to infinity. So this one is discussed in section 12.3. This is the exponential function. Now, the inverse function of exponential function. So here we have y equal b to the power x. This is exponential. To find the inverse, just change the positions for x and y. So y becomes x, x becomes y. So this is the inverse. So the inverse of y equal b to the power x would be x equal b to the power y. Now, the graph of the inverse function would have the points. So the inverse function will passing through 1, 0 and b1. Just flip these two ordered pair. So if the exponential passing through 0, 1 and 1b, so now the inverse function passing through 1, 0 and b1, just flip these two ordered pairs. Now, the domain for f inverse is the range for the exponential. So the range here is 0 to infinity. This is for exponential. So for the inverse function, this one becomes the domain for f inverse. And the range for f inverse is minus infinity to infinity, which is the domain for the exponential function. Negative infinity to infinity. Now to graph, now to solve the inverse function x equal b to the power y for y, we need the following definition, which is called logarithmic function. So if b greater than 0 and b not equal 1, the logarithmic function with base b is defined by the equation y equal log x with base b if and only if x equal b to the power y. So here, if you look at this, y equal log with base b of x. So we start from the base. So b to the power y, b to the power y equal x, equal x. So now this logarithmic function is equivalent to this exponential. Y equal log with base b of x equal x equal to the b to the power y. The domain, as mentioned before, the domain of the logarithmic function is 0 to infinity. So here the logarithmic function is the inverse of the exponential. And the range of the logarithmic function is minus infinity to infinity. So now what is log 1 with base 4? Log 1 or log 1 with base 4 equals 0 because So here we start from the base. The base is 4. So 4 to the power 0 equal 1. It is clear that 4 to the power 0 is 1. Any number to power 0 is 1. Log with base 5 of 25 equal 2, because, so here the base is 5. So 5 to the power 2 equal 25. So 5 squared is 25. And so on. Log with base 5 of 1 over 25 equal negative 2, because, so we start from the base here is 5. So 5 to the negative 2 equal 1 over 25. So 5 to the negative 2 is 1 over 5 squared, and 1 over 5 squared is equal 1 over 25. And similarly here, log with base 2 of 1 over 8 equal negative 3, because 2 to the negative 3 equal 1 over 8. 2 to the negative 3 is 1 over 2 cube, and 1 over 2 cube is 1/8. Log with base b of x equal y, because b to the power y equal x. And log with base b to the power x equal x, because we start from the base is b, so b to the power x equal b to the power x. Objective 2, graph a logarithmic function. So if we need to graph this function, a logarithmic function, y equal log with base 2 of x, so first convert this logarithmic function into exponential. So now y equal log with base 2 of x is equivalent to this exponential. So we start from the base. Base here is 2. So 2 to the power y equal x. So now this logarithmic function is equivalent to this one, to this exponential. Now let us graph this exponential, which is equivalent to logarithmic function. So to graph x equal to the 2 to the power y, so here y is the independent variable and x is depending. So let us first take values for y, then find x. Then we rewrite the ordered pair xy. So here, if y is negative 2, so 2 to the negative 2 is 1 over 2 squared, and 1 over 2 squared equal 1 over 4. If y equal negative 1, so 2 to the negative 1 equal 1/2. If y equals 0, so 2 to the power 0 is 1. If y equal 1, so 2 to the power 1 is 1. And if y equal 2, so 2 squared equal 4. So now the ordered pair, so here we have xy. So this is x, and this is y. So the first ordered pair is 1 over 4, then negative 2. Then the second ordered pair is 1/2, here x is 1/2, and y is negative 1, and so on. Now graph this ordered pair on the plane. So the first one is 1 over 4, negative 2. So suppose this is, move one corner to the right, then negative 2, so we get this point. Then 1/2, negative 1, we get this point. 1, 0, then 2, 1, then 4, 2. This point is 4, 2. Now graph a smooth curve passing through these points. So this is the graph for x equal 2 to the power y, which is equivalent to y equal logarithm x with base 2. If you look at this graph is increasing. When x increased, y is also increased. Let us take another example. If the base is between 0 and 1. So here in this example, the base is 2, which is greater than 1. Let us take the base b between 0 and 1. So for example, graph y equal log with base 1/2 of x. So to graph this logarithmic function, so first convert to exponential. So we start from the base is 1/2. So 1/2 to the power y equal x. So 1/2 to the power y equal x. So now let us graph this exponential. So first, so here x depending on y. So first let us take some values for y, then find x. So if y equal -2, -1, 0, and 1, now find x. Just substitute -2 for y. So we get 1/2 to the -2. So here the exponent is -2. So use the properties of exponent. So flip this fraction. So we get 2 over 1. Then change negative to positive. So 2 over 1 is 2. Square equal 4. If y equal -1, so we have 1/2 to the -1, which is equal 2 over 1 to the power 1. 2 over 1 is 2. To the power 1 is 2. 1/2 to the power 0, any number to power 0 equal 1. Then 1/2 to the power 1 equal 1/2. So now write the ordered pair xy. So first x is 4, y is -2. So 4, -2. The second ordered pair, x is 2, y equal -1. So 2, -1. And so on. Now graph this ordered pair in the plane. So we will get a smooth curve like this. If you look at this graph is decreasing. Why? When x increased, so here, when x is increased, so look, or here, if x is decreased, y is increased. So here x is 4, 2, 1, 1/2. X here is decreased, while y is increased, -2, -1, 0, and 1. So now this graph is decreasing, passing through 1, 0, and b1. B here is 1/2. Why? Because this is the logarithmic function, which is the inverse of the exponential function. If the exponential passing through 0, 1 and 1b, the logarithmic function passing through 1, 0 and b1. So in this example, b is 1/2. Now, the graphs of all logarithmic functions are similar to those in figure 1 and figure 2. So this is figure 2, and the previous one was figure 1. So if b greater than 1, if the base b greater than 1, the logarithmic function is increasing as in figure 1. While if b between 0 and 1, if b greater than 0, less than 1, the logarithmic function is decreasing as in figure 2. Objective 3. Solving logarithmic equations. As we mentioned before, so the properties of logarithms, log with base b of b equal 1, because b to the power 1 equal b. And log with base b, b to the power x equal x, because b to the power x equal b to the power x. And log with base b of 1 equals 0. So log 1 for any base equals 0, because here we start from the base, b here is the base, so b to the power 0 equal 1. So here we have, remember, if y equal log with base b of x, b is greater than 0, b greater than 1, the domain for the logarithmic function is 0 to infinity, and the range is minus infinity to infinity. Conversion formula. If x equal b to the power y, then y equal log with base b of x. So now these two are equivalent. The logarithmic function is equivalent to this exponential. Now solve the following logarithmic equations. For example, let us solve this example. Log with base 3 of 9 equal x. To solve this logarithmic equation, so first, convert to exponential form. Convert to exponential form. So let us convert it. We start from the base. The base here is a 3. The base is a 3. So 3 to the power x equal 9. Second, solve for x. If x is in the exponent position, so here x is the exponent position, x is the exponent, convert both sides of the equation to have the same base. Now convert both sides. So 9 we can rewrite it like 3 squared. So now we have the same base. Then use the property. If b to the power x equal b to the power y, then x equal to I. So here, since the base is the same, 3 is the same base, so the exponent should be equal. So therefore, x equal 2. So this means that log with base 3 of 9 equal x, x here is 2. So this means this log equal 2. Another example. Log with base 4 of x equal 1/2. Now to solve this logarithmic equation, so convert to exponential. So we start from the base. The base is 4. So 4 to the power 1/2, 4 to the power 1/2 equal x. And 4 to the power 1/2 is the square root of 4. Square root of 4 is 2, so x equal 2. Another example. Solve this logarithmic equation. Log with base 2 of x equal 4. So first convert to exponential. We start from the base. So 2 to the power 4 equal x. 2 to the power 4 equals 16. So x equals 16. Objective 4. Evaluate a common logarithm. Base 10 logarithm. When the base b is not indicated in the notation like this, log x, so here the base is not indicated. we assume that b equal 10. So for example, log x, if we see like this, log x, so here the base is not indicated. This means that the base is 10. This is called common logarithm. For example, log 10 cube equal x, find x. So here the base is not indicated. This means that the base is 10. So we put b equal 10. Now to solve this logarithmic equation, first convert to exponential. So we start from the base. The base is 10. So 10 to the power x equal 10 cubed. Now use the property, if b to the power x, use this property, if b to the power x equal b to the power y, then x equal y. So here, since the base is the same, so here we have the same base, 10, 10. So therefore the exponent should be equal, so then x equal 3. Another example, find log 10 to the negative 2 equal x, so find x. Also here, this is common logarithm because the base here is not indicated. So if it is not indicated, this means the base is 10. So 10, now to solve this equation, convert to exponential function. So this logarithmic equation is equivalent to 10 to the power x equal 10 to the negative 2. Now since the base is the same, so the exponent should be equal, so x equal negative 2. Thank you.